This is the video for 5.1c activity. Too big or not too big? That is the question. It starts off by doing a jump start. The jump start has you answer 5 questions. The first question says find at least 5 coordinate pairs, x and y, that make the following inequality true. So we need to basically find 5 coordinate pairs that are less than or equal to 20. So I'm thinking 0, 0 is a good coordinate pair. I replace x with 0. 2 times 0 is 0, plus 4 times 0 is 0. So 0 is less than 20. Totally works. I think 1 and 1 will work. So that'll add up to 6. That's less than 20. 2 and 2 will work. That will be 4 plus 8. That is 12. That's less than 20. I wonder if 3 and 3 will work. Let's try it. 2 times 3 is 6, plus 4 times 3 is 12. That's 18. That will work. 3 and 3. And then we need one more. How about like 0 and 1? So 2 times 0 is 0, plus 4 times 1. 4 is less than 20, so that works. Okay, now we'll go ahead and look at the following statements, and we need to turn them into inequalities. And it says, remember to define your variables. Okay, so I'm going to choose variables for each of the items in here. So for number 2, it says it will cost at least $50 to purchase 2 different video games. So that's 2 different variables. So I have my first video game, and I'm just going to call that X. And second video game, and let's just call that Y. And it says that has to be at least $50. So greater than or equal to 50 has to be my first and second video games. Okay, so this is what we end up with. Let's go ahead and check out number 3. In number 3, we expect that at most 60 children and adults will attend the family reunion. So let's set children as X and adults as Y. So I know that X plus Y at most 60, so less than or equal to 60. So that's our inequality there. Okay, number 4. No more than 30 minutes should be spent preparing breakfast and lunch. Let's do breakfast as B, lunch as L. So no more than, so less than or equal to 30 minutes. B plus L. Okay, let's try our last one. Number 5. The total cost for a morning and afternoon snack should not exceed $10. Let's do morning as M, afternoon as A. So M plus A, not exceed $10, less than or equal to $10. What we've been doing here is we've been creating combinations of terms in an inequality. So it's actually in standard form where both variables are on the left and we have a constant on the right. We probably will need this as we head into our activity. Okay, let's turn the page. On the next page, we have our launch. So this explains the activity. It says, as Carlos is considering the amount of money available for purchasing cat pens and dog runs, he realizes that his father's suggestion of boarding the same number of each, perhaps 12 cats and 12 dogs, may not be reasonable. Why? So just a reminder that they've got $12.80 to spend, and cat pens are $32 each, and dog runs are $80 each. So that's good to remember. If I were to solve this using 12 cats and 12 dogs, I would just say, well, $32 times my 12 cats plus $80 times my 12 dogs. How much is that? Hopefully it's $12.80 or less. It actually is $13.44, which is definitely too much. Okay, so that's a problem. In part A, number 1, they want us to find at least 5 more combinations of cats and dogs that are too big, just like 12 cats and 12 dogs was too big. And then it wants us to plot the points using the same color for each point. So let's go ahead and do that. I'm going to build a little table here to help me find my ordered pairs that are too big. So let's do cats first, then dogs, and our cost. If I do 12 cats and 13 dogs, that's going to cost $14.24. If I do 10 cats and 15 dogs, we're still over. It's $15.20. If I do 10 cats and 14 dogs, it's $14.40. Okay, so still over. If I do 16 cats and 16 dogs, $17.92. Okay, definitely over. And then 10 cats and 20 dogs, that will be $19.20. So definitely all of these are too expensive. Let's go ahead and graph them. So it looks like I have 0, and I think a good scale here is going by 2s. So let's say 2, 4, 6, 8, 10. I think that'll be a good scale for us. And then 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. And we'll do the same thing. This is going to be cats over here for X. And then we'll label our Y axis as well. And this is going to be dogs. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. Okay. So let's just use red, and we'll use a different color for part B. So 12 and then 13. So 12, 13 is like right here. And then 10 and 15, like right there. 10 and 14, right there. 16 and 16, right there. Oops. And then 10 and 20, so right there. Okay, so those are all combinations that are too big. Okay, I'm going to switch colors now and find at least 5 combinations of cats and dogs in part B that are not too big, so ones that do not use all of the money. So let's go ahead and build a little table and create those 5 combinations. So we've got cats, we've got dogs, and cost. So for cats, let's do like 4 and then 4 dogs. That's $4.48. That's definitely under budget. Let's try maybe 10 cats and 4 dogs. $6.40, still under budget. 10 cats and let's try 8 dogs. That is $9.60. Okay, 4 cats and 8 dogs. That's $7.68. And then let's do 8 cats and 8 dogs. That's $8.96. So all under budget. These are all not too big. So let's graph those and see where they end up. So 4 and 4 is right here. 10 and 4 right there. 10 and 8. 4 and 8. And 8 and 8. There. Okay. Okay. Now part C has us find 5 combinations of cats and dogs that would be just right. And I'm going to switch the color here again like it wants us to. So let's go ahead and build a table and find 5 just right combinations, ones that are exactly $12.80. So cats, dogs, cost, and then under cost, I know all 5 combinations are going to be exactly 1280, so I can fill that out ahead of time. Okay, so let's see. What if I do 0 cats? If I do 0 cats, I can do 16 dogs. And all I do is find that by doing 1280 divided by 80, the cost of the dogs. What if I do, let's say, 5 cats? Then it's going to be 14 dogs. What if I do 10 cats? It's going to be 12 dogs. If I did 15 cats, it's going to be 10 dogs. And if I do 20 cats, it's going to be 8 dogs. Hopefully you can kind of see a pattern going on here. Every time I add 5 cats, I lose 2 dogs. So that's actually really interesting. We'll talk about that more in number 3. Okay, so let's go ahead and graph these points using green. So 0 and 16 is right here. Okay, and then 5 and 14, 10, 12, 15, 20, and I could just keep on going because I know the pattern. Right here, right here, and then it kind of goes off the screen. And this last group of points, we actually want to connect their points with a line. Okay, so what are we seeing? What are we noticing about the 3 different collections of points? So what I'm noticing is that my points that are just right form a line. My points that are too big are above that line, and the ones that are not too big are below. So let me fill in what I'm noticing here on number 2. So just right. Let me zoom in a tiny bit. Just right. Points form a line. Too big. Points are above the line. And then not too big. Not too big. Points are below the line. Okay, so that's pretty interesting. Number 3 wants us to write an equation for that line. So let's go ahead and do that. I can write, so let's look at the graph right here. So I can write an equation in 2 different ways. I can do standard form, which is basically recognizing that 32 times the number of cats plus 80 times the number of dogs equals our cost. And in this case, we want it to be, what was it, 1280. So we could write an inequality that way. So let me transfer that down to number 3. 32 cats plus 80 dogs could be equal to 1280. So that could be our equation. And I probably shouldn't have written it up here. Under part A, I probably should have written that over here under part C, because this is the one that equals 1280. So this is really where this goes. 32 times the cats plus 80 times the dogs equals 1280. Okay. Or I can write a slope-intercept form equation. So if I look at the graph, looks like my y-intercept is 16, and it looks like I go down 2 dogs and then right 5 cats. So let's fill that in as an alternate equation. Y equals down 2 dogs, right 5 cats, x plus 16. Now it says here, what does the slope of the line represent? And I kind of already said it. So negative 2 over 5 means for every 2 dogs, I can have 5 cats. And it's every 2 dogs kind of that I take away. So like kind of like lost. I can have 5 cats. That replaces it. Okay. All right, let's look at part 4. Shade all the points on your corresponding grid that satisfy the startup costs. Awesome. So we're going to go to the grid and we're going to shade where we have all the points that work. So I think the shading is going to be down here. These are all the ones that work. They satisfy the startup cost constraint. Okay, so that one's easy. So that is number 4. It's done. Now write a mathematical rule to represent the points shaded in problem number 4. You know what? I think we can write an inequality that pretty much looks like number 3. Either of the equations in number 3. But instead of an equal sign, we'll turn it into an inequality symbol. So 32x plus 80y, and instead of equals, we shaded below, so we're going to do less than or equal to 1280. And we can do the same thing for the other one. Y is less than or equal to negative 2/5 x plus, what was it, 16. Okay, so those are inequalities that represent all the answers under the line or equal to it. Okay, let's go ahead and try number 6. In number 6, they have you, instead of looking at the startup costs, they have you look at how much space is available. And we're going to do the same thing. We're going to write an inequality and graph it. So we're modeling the situation using algebra. So what would the inequality be to represent the solution set for space? So it looks like there's 6 feet of space for each cat. So that's just 6x, and 24 feet of space for each dog, so plus 24y. And that has to be less than or equal to 360 feet. Now, once we have this, we can change it to slope-intercept form, or we can graph it using kind of the extremes, all cats and or all dogs. So I'm going to show both ways. Let's first solve this for y. So we'll show that way first. Minus 6x from both sides. 24y less than or equal to negative 6x plus 360. Divide everything by 24. And we'll have to do some simplifying here on the right. So y is less than or equal to negative 1/4 x plus 15. So this is one way to graph standard form. So up here, this is standard form, and we can switch it to slope-intercept form, and then it's a little easier to graph. Okay, so I'm going to graph that right now. Show you what it looks like. This will be dogs over here, y. This will be cats over here, x. And I think I'm going to go by, let's go by 5s. So 5, 10, 15, 20, and 5, 10, 15, 20, 25, 30, 35, 40, 5, 10, 15, 60. Okay, we'll label up here a little bit too. 2, 3, 4, 40. 1, 2, 3, 4, 60. Okay, so looks like my y-intercept is 15. So I put a point here at 15, and then I'm going to go down 1 dog, right 4 cats. Down 1 dog, right 4 cats. Down 1 dog, right 4 cats. So I can I can even go down 5 dogs, right? 20 cats. That's like the same thing as down 1, right? 4. And that will get me my line. Okay. Now I could have also graphed this using kind of the extremes. So I'm going to show that method as well. So let's say I'm going to do a little table. This is cats as X, and dogs is Y. So let's say I have 0 cats. If I have 0 cats, then all the space will be for the dogs. So I can do 360 divided by 24 per dog, square feet per dog, and that's going to be 15 dogs. If I do all dogs, or 0 dogs and all cats, I put a 0 here, and then I'm going to have 360 divided by the space per cat. That'll be 60 cats if I have no dogs. So if I, rather than solving 6x plus 24y is less than or equal to 36, instead, if I just found the extremes for that, setting x to be 0 and solving for y, 15 dogs, and then setting y to be 0 and solving for x, 60 cats, I could just graph it using these 2 points. So 0, 15 is right here, and 60, 0 is right here. So I get the same line right there. The last thing to do is shading. So I'm going to shade where I have all my solutions. Looks like it's less than, so we're going to shade under here. Okay. What do you think? What recommendation would you give to Carlos and Clarita regarding how many cats and dogs to plan on boarding? So this would be my final recommendation. Choose a combination of cats and dogs that is in both of the shaded graphs. So for space, I want a combination that is somewhere under here. And then I'd have to go to my cost graph and make sure that the combination I chose is in that shaded area too. So choose a combination of cats and dogs that is in both shaded areas. Okay, so that is my final recommendation. Let's go ahead and do our takeaways, and then we will be done with this activity. So last page. Linear equations can be written in the following form. Standard form, ax plus by equals c. This is when the x and the y are both on the left side. Slope-intercept form, y equals mx plus b. The y is by itself. We have the x with the slope and the y-intercept on the right. I'm not going to cover point-slope form, so don't worry about that. The solution set to a linear inequality is a half plane. That is, it's the set of all points in the shaded region. Okay, so I'm just going to say it's all the points in the shaded region. Okay. The solution set to an inequality constraint for the context like pet sitters is all the solutions that are in both shaded regions. Okay, and then we're going to finish up with our last takeaway. The boundary line for a linear constraint can be written as standard form. And what's nice in standard form is that standard form reveals the combination of terms. Or we can use slope-intercept form. And what's nice about that, it reveals the rate of change. For example, for the cost constraint, our rate of change was negative 2/5. For every 2 dogs that we lose, we can gain 5 cats. For the space constraint, it was negative 1/4. So every 1 dog that we lost, we can gain 4 cats, which some of you noticed when you were doing this last week. So it's good to notice those exchange rates because that's part of that's the slope in the slope-intercept form. In summary, in this lesson, we learned how to find and represent all the points in the solution set for a linear inequality into variables. I hope that this video helps, especially those who were absent, and I wish you good luck on your practice.